Starbase Timeline has just revealed some groundbreaking developments as the megapad at Starbase is undergoing an exciting upgrade. Also, the OLM Foundation at Starbase has been bustling with activity, with significant advancements as it prepares for the next Starship launch. But that's not all. The long-awaited launch of the Dragon cargo mission to the International Space Station is finally on the horizon. There's also news about 22 Starlink V2 mini satellites, which has been delayed on Sunday morning. How does the megapad upgrade promise to push the boundaries of space exploration? Dive into this video to find out. As the Starbase construction and expansion project continues to unfold, significant progress is being made at the orbital launch mount. The sheer scale of the ongoing work is truly inspiring, with a focus on laying foundations and creating a robust infrastructure. Deeper into the latest updates from the site. A crucial aspect of the construction process is the creation of a strong foundation system for the steel sandwich structure. Given the site's location in wetlands, where the water table is close to the surface, preventing soil instability and water seepage is vital. To address this, the crew has been diligently driving in sheet pilings, providing stability and reinforcing the foundation. These pilings play a crucial role in securing the structure, and their strategic placement ensures the project's long-term success. The next step involves excavating soil around the orbital launch mount base to facilitate further construction. The pile casings, which encase the pilings, are being carefully cut down to ensure optimal integration of concrete and rebar into the pile cap. The pile cap serves as the interface layer between the heavy load at the top and the pilings beneath. It will eventually support the water-cooled steel sandwich at the top and the interconnected pilings at the bottom. Currently, the rebar work for the pile cap is underway, marking a significant milestone in the construction process. In the area of the water deluge tanks, continuous flight drilling rigs tirelessly continue their work. These rigs are instrumental in creating the necessary infrastructure for future expansion. Observations indicate the welding of another pipe with 3 T-joints, indicating the arrival of additional tanks in the near future. SpaceX has also made progress by extending the existing pipes for the deluge system, reinforcing them with concrete and painting them white. These enhancements demonstrate the continuous efforts to enhance the efficiency and reliability of the infrastructure. Turning our attention to the orbital tank farm, the construction team is diligently digging new pilings and expanding the walls around the horizontal methane storage tanks. This expansion is likely a preparation for the arrival of new tanks to comply with safety and regulatory requirements. Although the new tanks are not expected to store liquid oxygen at this time, necessary measures are being taken to ensure optimal functionality and adherence to industry standards. Significant developments are also underway to address power supply requirements at the Starbase launch site. A trench has been dug out from the build site to the launch site, indicating the installation of substantial power cables. This exciting progress suggests that a reliable and robust power supply system will soon be established. With the trailer generators removed, temporary power constraints exist, rendering large equipment such as the orbital tank farm motors and drawworks hoist temporarily unavailable. However, this situation presents an opportune moment to transition these systems to the main power lines, a step that will enhance efficiency and long-term operations. In other news, Booster 10 recently emerged from the Mega Bay after being lifted onto its new transport stand. SpaceX employs a rig that connects the 2 bridge cranes within the Mega Bay to increase lifting capacity. Booster 10 then made its way to the Sanchez site, where it joined Booster 4. This development underscores the steady progress being made in the assembly and preparation of the boosters for future missions. One of the notable achievements is the full stacking of B11, the latest booster in the lineup. As the 3rd flight-worthy booster to be fully assembled, B11 joins the ranks of its predecessors, ready to contribute to future space missions. Workers at the orbital tank farm have been diligently repairing the damaged outer shell of one of the water tanks. As we delve into the latest updates, Ship 26, while stationed nearby, remains on the engine installation stand, with no immediate plans for relocation to the rocket garden. It becomes evident that SpaceX utilizes this location not only for storage, but also for future flight vehicles, igniting anticipation for what lies ahead in their missions. Ship 29, another key player in the Starbase saga, continues its rapid progress. Stacking operations are well underway, with the thrust section now being carefully shifted toward the nearby highway. Furthermore, remarkable strides have been made in constructing the new Mega Bay. All 4 sections of the second layer have been skillfully assembled, and some of them have already received their protective cladding. The assembly of a primary section for the third layer is also in full swing. With the first layer of the mega bay almost complete, except for the cladding stage, it is evident that the construction of this colossal structure is well on its way. One notable addition to the Starbase landscape is the fully built-up LR11000 crane, which has made its way from the Roberts Road site in Florida. Witnessing the crane's presence among the construction activities signifies the scale and magnitude of the ongoing operations at Starbase. Turning our attention to the expanding Star Factory site, the concrete flooring has expanded considerably, with only a few remaining sections awaiting completion. These areas, once cleared, will be filled in, laying the foundation for potential future developments. Notably, there appears to be a pit within the site, igniting speculation about its purpose. This pit could potentially house a hydraulic press for die stamping, a crucial element in various parts of the Starship build process. The addition of on-site manufacturing presents an exciting prospect, offering the potential to reduce shipping costs and optimize the prototype builds of both ships and boosters. A significant transformation is underway within the Starbase area, as evident from the demolition of the low bay building, accompanied by the removal of neighboring structures dedicated to ground fabrication and propulsion. The skyline of the area is rapidly evolving, marking the advent of a new era in space exploration. Venturing deeper into the vast Starbase site, the foundations for additional footings come into view. This area is anticipated to house cryogenic tanks at the rear of the site, showcasing SpaceX's dedication to advancing cryogenic technology. Notably, the remains of Booster 6, which met its demise during a test, suggest that this location will serve as the future site for cryogenic testing on booster prototypes. This strategic decision enables more efficient testing procedures, eliminating the need to conduct tests at the heart of Starbase. Progress marches forward as the completion of the main pilings at the site is celebrated. With this milestone achieved, attention now shifts to the initiation of rebar work, further reinforcing the structure and bringing it closer to its final form. Finally, we turn our sight to the Florida site, where activities have somewhat slowed down. The completion of the highway-related tasks has prompted the relocation of equipment and resources to Starbase, Texas. The latest reports reveal that this week alone, an impressive number of 15 to 18 piles have been drilled, marking significant progress in the construction process. Notably, the smaller piles require a different approach, with cages measuring just about a foot in diameter. The efficiency and speed at which these piles are completed is truly remarkable, as the continuous flight augering (CFA) technique allows for swift drilling and concrete filling. Speaking of construction techniques, Starbase's use of CFA stands out as an intriguing method. The CFA process involves utilizing a long drill bit to penetrate the ground continuously. This eliminates the need for manual extraction, as the drill bit lifts the dirt as it progresses. Once the desired depth is reached, concrete is pumped through the drill bit, filling the hole efficiently. A rebar cage is then inserted into the wet concrete, solidifying the structure. It's fascinating to witness the speed at which multiple smaller piles can be drilled in a single day using this technique. Venturing deeper into the construction site, we discover the intricate network of thick rebar that reinforces the structures, ranging from 1.5 to 1 3/4 inches in diameter. These rebar placements resemble a complex web of large spaghetti, ensuring the structural integrity of the orbital launch mount and the cryotanks. It's truly a marvel to witness the coordination and expertise required to install this crucial component of the construction process. Observing the overall site, one can't help but notice the continuous activity. The concreting and digging processes are in full swing, contributing to the dynamic nature of the work environment. Projects such as the construction of new cryo-tanks are well underway, with significant progress being made. A significant development at the site is the construction of a landing pad, which is estimated to be 3 to 4 feet thick in concrete, layered with a substantial amount of rebar. This robust foundation will serve as a solid base for future launch operations. The attention to detail in constructing such a durable pad highlights the meticulous approach taken by the team in ensuring the longevity and reliability of the infrastructure. One noteworthy addition is the formwork being installed for the 6th methane tank within the tank farm. This additional tank provides Starbase with increased residual storage capacity, reducing the need for frequent refueling operations. The 24-hour hold period, although slightly unconventional, allows for proper vehicle repropellantization. It is anticipated that future launches will significantly reduce this hold period, streamlining the launch process and improving operational efficiency. As construction progresses, a retaining wall has caught the attention of observers. This wall, extending beyond the required dimensions, suggests that it is likely the beginning of a structure that will enclose the upcoming section of the tank farm. This additional enclosure is expected to match the existing height and expand the capacity of the tank farm, further enhancing Starbase's capabilities. In other developments, progress is evident in the reassembly of the orbital launch mount. Most of the quick disconnects have been reinstalled, with attention now focused on the installation of clamps and aqua-colored actuators. The purpose of these actuator components, accompanied by attached plates, is yet to be confirmed. Observers note that these components should have remained in place, raising questions about their removal. It is likely that the clamps and associated actuator parts are undergoing modifications to accommodate higher loads and enhance their functionality. The current design utilizes the clamps to tightly secure the booster by gripping the lip and holding it down against the ring connected to the outer 20 engines. However, the existing configuration may not withstand the full liftoff force of the vehicle, leading to automatic release during launch. Therefore, improvements are expected to reinforce the hold-down mechanism and ensure its ability to withstand the forces exerted during liftoff. Excavation activities around the pilings have been noteworthy, as a long-arm excavator places a layer of large rock, transitioning to smaller rocks. This rock placement serves as a preparatory step before pouring the slip layer of concrete and installing forms for the pile cap. Discussion and speculation surround the presence of 3 manifolds at the construction site. Questions arise regarding the storage and distribution of these essential components. While the purpose of these manifolds remains elusive, experts believe that a total of 6 sets of plates will be required for future operations. One noteworthy addition is the formwork being installed for the 6th methane tank within the tank farm. This additional tank provides Starbase with increased residual storage capacity, reducing the need for frequent refueling operations. The 24-hour hold period, although slightly unconventional, allows for proper vehicle repropellantization. It is anticipated that future launches will significantly reduce this hold period, streamlining the launch process and improving operational efficiency. As construction progresses, a retaining wall has caught the attention of observers. This wall, extending beyond the required dimensions, suggests that it is likely the beginning of a structure that will enclose the upcoming section of the tank farm. This additional enclosure is expected to match the existing height and expand the capacity of the tank farm, further enhancing Starbase's capabilities. In other developments, progress is evident in the reassembly of the orbital launch mount. Most of the quick disconnects have been reinstalled, with attention now focused on the installation of clamps and aqua-colored actuators. The purpose of these actuator components, accompanied by attached plates, is yet to be confirmed. Observers note that these components should have remained in place, raising questions about their removal. It is likely that the clamps and associated actuator parts are undergoing modifications to accommodate higher loads and enhance their functionality. The current design utilizes the clamps to tightly secure the booster by gripping the lip and holding it down against the ring connected to the outer 20 engines. However, the existing configuration may not withstand the full liftoff force of the vehicle, leading to automatic release during launch. Therefore, improvements are expected to reinforce the hold-down mechanism and ensure its ability to withstand the forces exerted during liftoff. Excavation activities around the pilings have been noteworthy, as a long-arm excavator places a layer of large rock transitioning to smaller rocks. This rock placement serves as a preparatory step before pouring the slip layer of concrete and installing forms for the pile cap. Discussion and speculation surround the presence of 3 manifolds at the construction site. Questions arise regarding the storage and distribution of these essential components. While the purpose of these manifolds remains elusive, experts believe that a total of 6 sets of plates will be required for future operations. The shift towards self-sufficiency is a crucial element in the ongoing transformation of Boca Chica. By reducing dependency on external suppliers and streamlining transportation, the Starbase can create a self-sustaining system that significantly improves its capabilities. This integrated approach ensures that all necessary resources are readily available on site, strengthening the foundation for future space missions. The evolution of the Boca Chica vision has been captivating to witness. Initial plans for on-site production of methane and liquid oxygen have given way to a strategy that leverages existing infrastructure in the surrounding area. Collaboration with the Texas LNG facility and the potential establishment of a cryogenics pipeline network demonstrate a forward-thinking approach that maximizes available resources. Stay tuned for more updates as this incredible journey continues to unfold. Up next, SpaceX launched Dragon cargo mission to space station Sunday after one-day delay. After a one-day weather delay, SpaceX successfully launched its 28th cargo mission to the International Space Station on Sunday. The mission aims to deliver essential supplies and equipment to the astronauts aboard the orbiting lab. The cargo mission was initially scheduled for Saturday, June 3rd, but was postponed by 24 hours to allow more time for vehicle preparations and for weather conditions to improve. Although there was a 60% chance of unfavorable weather on Sunday, it was still a slightly better outlook compared to the 70% odds of bad weather on Saturday. The SpaceX Falcon 9 rocket is entrusted with the responsibility of launching the robotic Dragon cargo capsule toward the ISS. The launch took place at 12:12 p.m. from NASA's Kennedy Space Center in Florida. The Falcon 9, known for its reliable performance, carried the uncrewed Dragon capsule on a course with the ISS. Once the Falcon 9 completes its primary task, the first stage of the rocket will separate and undergo a boost-back burn. This venture will propel the stage back towards Earth, where it will perform a precise landing on SpaceX's autonomous drone ship named a Shortfall of Gravitas. The drone ship will be stationed in the vast expanse of the Atlantic Ocean, ready to receive the returning booster. Meanwhile, the Cargo Dragon spacecraft embarks on its journey towards the ISS. It will spend just over 40 hours traveling on an intercept course with the space station. The Dragon is expected to catch up with the ISS early Monday morning and is scheduled to dock at the Harmony module's Zenith port at 5:36 a.m. One remarkable aspect of SpaceX's Cargo Dragon is its reusability. Similar to its crewed counterpart, the Cargo Dragon is designed to return to Earth for soft, parachute-aided ocean splashdowns. At the end of its stay at the ISS, the Dragon will carry scientific samples from over 34 investigations back to Earth. These samples are crucial for ongoing research and scientific advancements. Dragon cargo mission to space station Sunday after one-day delay. SpaceX's highly anticipated Starlink launch faced a setback due to unfavorable weather conditions. The launch, originally scheduled for Sunday, had to be delayed, leaving space enthusiasts eagerly awaiting the new launch date. The Starlink mission involves the deployment of 22 advanced V2 mini satellites to expand SpaceX's revolutionary communications constellation. These satellites are equipped with cutting-edge technology, providing greater broadband capacity and improved internet connectivity worldwide. Their deployment plays a crucial role in bringing reliable and high-speed internet access to even the most remote areas of the globe. However, the weather had other plans for this ambitious launch. SpaceX announced that the launch had to be postponed due to bad weather at the Florida launch site. Only a 15% chance of good weather was expected at the scheduled launch time, making it too risky to proceed. Safety is of utmost importance in space missions, and launch conditions must be optimal to ensure a successful and secure liftoff. As a result, SpaceX has set its sights on a backup launch opportunity. The new launch time is scheduled for Monday, June 5th, with multiple possible time slots. While the delay may be disappointing for those eagerly anticipating the Starlink launch, it is important to remember that these launch decisions prioritize the safety and success of the mission. Weather conditions play a significant role in the liftoff process, and launch teams must carefully evaluate the risks before proceeding. SpaceX's commitment to innovation and pushing the boundaries of space technology remains unwavering. The Starlink constellation, already consisting of over 4,000 satellites, aims to revolutionize internet connectivity on a global scale. The company has regulatory approval to launch up to 12,000 additional satellites and is even applying for permission to add a staggering 30,000 more to the project. That was all the space news for today. How near are we to the next Starship launch? Share your views in the comment section below. And if you want to see more interesting videos, don't forget to subscribe with all notifications enabled so you don't miss out on the latest news on space.